Okay, let's pick up where we left off last time. I'm here trying to formalize the Schwartz-Zippel Lemma. Right, so last time we had this like really long calc block, and what I did is I factored some of the lemmas out of this calc block that I needed, and I just put them up here. So we only have a few saris left, right? We have this sari at the end, which ultimately was some lemma about particular natural subtraction being valid. And we have a bunch like these two saris are like the sort of critical ones that have to do, I think, with sort of messing around with sizes of filtered fin sets and proving that one is less than or equal to the other. And then we also have some sort of minor saris up here. In fact, I think I noticed this yesterday. H0, P prime coefficient, total degree. Right, so this is just P underscore I, right? And this is in fact similar to this one. Right, this one like follows from H0 basically. Anyway, that's something we'll get to towards the end, I think. And the other thing that I noticed is that I made this definition, function fin set, right? This is, okay, it's like some of these things are, I don't know what this is. This is some lemma about what happens when I filter that. But this is, yeah, I don't know if I'm gonna uncomment this or delete this. But function fin set, right? It's just supposed to be this, right? I have a type A and a type B, and A is a finite type, and S is a finite subset of B. And I just want the finite set of all functions from A that map into B. And I think what I had concluded or like recalled from last time was that somewhere in the probably a few months ago, I think there was something on the forum where I had asked about this. Let me check my sent messages. Can I search for fin set? Yeah, I can march fin set of all functions from a fin type to an image of the fin set. And I asked this exact question. I asked if we had that definition. And Eric Wieser gave the following solution. Which I will now copy and paste in. Interestingly enough, it's someone that uses sorry. But what he said was this. Now I think that maybe part of the issue here is that in lane 4, I think I have to put like a dot or something. Obviously, this has to be fin set capitalized, and this has to be fin set. Yeah, let me just delete this. I can like try and figure out why this code is supposed to give me what I'm. likes best also told me look at docs pi fin type. Here, let's put this visibility of the recording. This is right. This is interesting, right? It's like this is the version where B is itself a fin type, and it's just that, right? It's not that we have a finite set of B. It's that we're like B itself is finite, and it's talking about the type of all functions from A to B. And of course, it's dependent. I want something a little bit more general than that. But maybe he was just telling me, I think, that I have to add some decidability. Okay, let's try and understand why this function does what. What is this, and why is it the thing that I'm looking for? Okay, so finset.univ, finset A to S. Right. Okay, so this is, yeah, okay, I see what's happening here. So this is like S as a type. It's being coerced from a set to a type. And then, because it's a finite set, we can take the finite set of all, we know that the finset.univ. Right, so obviously we should be at least deriving the fact that functions from A to S is a finite type. And then presumably what this map does is put it back in terms of a function, like casts it to type A to B rather than from A to S. And I'm failing to synthesize. Yeah, I'm failing to synthesize. Exactly. Yes, this is actually something I brought up when I commented this question back in March, which is that I'm getting this error, which is I fail to synthesize this instance. That A maps to this. And AliExpress told me to look at Python type. Okay, let me take a look. Add some decidability assumptions. Okay. Yeah, lots of decidability assumptions always necessary. fintype.py finset. What is this? fintype.py finset. Said I can open locale classical. Okay, maybe we should find the like analogous thing in the MATLAB 4 docs. Data fin type pi. Okay. Of course, it's impossible to get it to work. MATLAB data fin type pi. Here it is. I think it was in BASIC as well. Let me read this again carefully. Is this what I want actually? Okay, we have A, which is a type, decidable equality, and fin type. Delta, like so what if I declare delta to be like the thing that maps all types to beta? And then T to be the thing that maps all fin types to S. Can I not use like this somehow? Okay, so what I want is like fin type dot pi fin set of T, or T is like a function, takes A and returns, well, S, right? Failed to synthesize equals decidable equal. Okay, well, I'll just put that right on in there. Maybe that. This might be correct. It has the type I want. Yeah, okay, I think this is right. Define the fin set of all functions taking values TA for all A. Right. And so for all A, like it takes a value in S. Yes. I think this is just exactly what I want. All right, cool. Did this exist before? And like now that I feel like this has been so simple, it's sort of surprising to me that they didn't know about it, but maybe they just were not aware of this, or maybe it's new or something. Okay. So we have this this definition. Apparently it's non-computable. Ooh, sorry. I just want to like get a sense of why it's non-computable. I think it complains at me if I call it non-computable and it's not non-computable. Oh, it's not complaining at me at all. Okay, so apparently it is computable. Because I've included decidable equality of A now, maybe? Yeah. Anyway, that sort of thing is mysterious. Okay, so let's now return to the like two sort of critical lemmas we now have to prove to finish off this theorem. And try to parse what's going on. Right, so the cardinality, when I filter, okay, so I'm actually proving like an equality of cardinalities here. So this is filtering those fin sets. Right. So I'm filtering like the function fin set, right? And I'm filtering exactly those functions such that when I compose with fin set, so what is the type of the functions I'm filtering? I think they're functions from fin, nad, suc, n, like fin of the successor of n to f. And then I filter out those such that when I evaluate on pi prime, or I filter only those such that p sub I prime is equal to 0. And the idea is that this should be equal to this time I'm doing functions from fin n to f rather than fin suc n to f. And still I must have, now I'm no longer composing with fin suc here. And the idea is that these are actually of equal cardinality. And the reason they're of equal cardinality is because there's a bijection between them. But the tricky thing is that currently I have finset.card here times finset.card s. Okay, so I think the first thing I want to do is take this right-hand side here and re-express like finset.card a times finset.card b should be equal to finset.card of a times b. So let's try and find the name of that lemma. Let's like search around in here. What would it like? Finset card mul card. That doesn't look right. Prod maybe. What's the name of product? Is this the name? What is the name for like the tensor product? Okay, this looks promising. What is this? This is okay. The Cartesian product is this set. This is interesting. Why isn't it the normal Cartesian product? Why is there this s here? Introduce the notation x. Okay, x times s y for the s prod of any s prod structure. How is s prod different from prod? Set product, as opposed to just like regular backslash times, which is for other kinds of products. It's a little mysterious to me. But I think that the key thing we want to do is rewrite using this thing. So, and we're going to rewrite backwards. Yeah, interesting to me that this is a simp lemma, but whatever. Rewrite fin set. Sorry, this should be backwards rewrite. Fin set dot card product. Okay, cool. Now I have this product. And so now I have two finset.cards, and I want to prove that they're equal. So yeah, a bit nervous about x to the s being, or this like backslash times s being different from what is it called? How is it written? Let me just copy it in here, mouse over it. Type, okay, so it's backslash times backslash up arrow s. Okay. But the next thing that I want to do is say that the cardinality of two sets are equal if there's a bijection between them. So finset dot card eq card. Maybe card eq of bijective. This looks right. Oh, but this is actually tragic because it's not of the form finset.card s equals finset.card s. Okay, what is going on? Right. N is just some natural number here. And what it's saying is that, okay, this is like especially weird because it's not, I would expect it to be something like f from fin n to alpha. Card conger, maybe this. Finset.card s equals finset.card t. Yeah, it's interesting that this is, like, at the very least, I would expect that, like, this would be replaced by, like, fin n. Like, this could also be replaced by fin n. But for whatever reason, that's not the case. Maybe it's because they want you to like prove these things separately or something. Maybe like maybe you always immediately unpack the fin n. Okay, so alpha is a type, beta is a type, S is a fin set of alpha, T is a fin set of beta. Yes, I think I have all of that. I want to prove that their cardinalities are equal. Okay, well, let me just like try applying this. Card conger. Right. All right, so there are meta variables later on. But the thing that I have to do is I have to provide like a function, yes, from A to B. Yeah. Right, it's sort of funny because I don't think I actually need like the A element of S condition, right? Because what's the like isomorphism that I'm trying to establish, right? So I have here functions from fin suck n to f, and here I have functions from fin n to f tensored with elements of f. And I presumably want to like compose them using like, I just need to sort of like glue those things together. So basically it's just like, so basically what I need to like establish is like the canonical bijection between those two like types, you know, ignoring this alpha in S. I wonder what the name of that is, right? So what I need to produce is a function right? Maybe I should just like start doing this, right? I should like a function which takes a, which is going to be a type. It's going to be a type, why am I blanking on this? Fin, suck, n to f. And it's going to return something. It's going to return something of type S, right? It's going to return something of type like fin, something of type fin n to f at times s. Apparently this is what it has to be, f. Type expected. Okay, but it needs to also have parentheses here. The set Cartesian product. Okay, maybe I'm like grossly, okay, it's like set Cartesian product. This is, let me just like take a quick step back here and like peruse what is the actual type of these things. Ah, okay. Okay, maybe I understand things a lot better now, right? The difference between \times and \times s is that \times is an operation on types and \times s is an operation on sets, which are not types. In which case, all I have to do here is remove this. And so I need to, so right now I need to like figure out what I'm going to put here. Right. Okay. The other like important thing to realize here is that I'm applying car to Conger, but this function that I'm applying has this like random thing that I'm not going to need. So let me like enclose this. Like, can I like start writing this on another thing? So I think I need this, and then I think I need to tell them that there's another. Okay. What I need is something that goes from natsuck n to f to fin n f. Fin n to f times f. Okay. Let me just like quickly like trying to find this in like a completely different place so that I don't like mess myself up. I'm defining a function who from any natural number n, in fact, I think I want this to be implicit. I have a, which is from type, A is going to be of this type. It's going to be of type successor of n, f. F is like made implicit. Yeah, okay, sure. I wonder if it would be easier to like do the symmetry first, actually. Because there's probably like something that takes in like an element of f and an element of fin natsuck, and an element of fin n to mapped to f, and then produces this function. I'm just gonna do this. Fin n to f times f. This I think needs to be in parentheses. Equals. I think I can do like this. is like, yeah, so like by exact. So I think it's like, okay, I think the key realization is that it's this, it's like composition with FinSoc, right? So right, FinSoc, what is FinSoc again? Okay. Is it circ A? I want something that first takes in I think it's actually like this. A circ. Yeah, it seems to be happy with that. And then the other one is going to be like A of 0 or something. What exactly does this do? Let me like quickly look at this. Right, it maps a fin n to a fin n suck, which adds 1. And then I want to like elim 0? I don't know if that's what I want. What I simply want is just, I want to like evaluate A at 0. Okay, this seems to have worked. Like, now it seems to me that there should be like a name for this function that maybe I'm not familiar with. Yeah, this is I'm all the way back in the in core, right? Or I'm in it. I am in init. Okay, so this is what it is, but I'm just gonna say it like in soft function. Okay, I think I'm okay with this. Returning here, what I think I want is like something that takes A and returns this. Let's see what the type checker thinks. Type checker seems okay. Okay, so what do I now have to prove? So like intro A. And I also have like HA. Okay, do I need intros or is intro sufficient? Okay, seems to be happy with that. So I have A, which is one of these functions, and I have HA, which says that A is in this sort of filter. Now I want to prove that this other thing is in this filter. It's in this filter times this other thing. I wonder what happens if I simplify. Like if I simplify, will it? The main thing I want now is, is that it's done this. Maybe before I simplify, I even want to do like unfold this. And now when I simplify, it's these two statements. Okay, but I'm simplifying too much. I don't want to simplify all this weird polynomial stuff. just want finset dot mem product and maybe finset dot mem filter. Let's take a look. Right, it's a member of a product if the first element is a member of the first product and the second element is a member of the second product. So yeah, I think I might be able to do this in the form of a rewrite. So now it's just this conjunction. You know, of course I want the I want to. Why does this give me all these things about polynomial.coef? I guess the point is that this is what the coercion is. It's interesting. I have to prove. It's telling me I have to prove 3 things. That's not what I expected. I guess I expected to have to prove 2 things, which is maybe this and the 3rd thing. Right, the key thing is so I basically have to get 2 facts out of HA, right? HA is a fact about this fin natsuck n to f function. But function finset, the fact that A is a member of a function finset, what that means is that A, if I decompose A into the fin n to f function and the element of f, that both of them I think I should rewrite this at A. Right, the fact that it's a member of the filter at A, this decomposes into 2 things. Mem filter. Okay, this is another one of those cases where I feel like I'm taking crazy pills. Oh, HA, there we go. So I think mostly I want to let's do this first before all this other stuff. First rewrite that. Then our cases j with j prime. So presumably this like decomposes it even more. Right. I mean, basically what I want to say, this is why I was thinking I might have wanted to change the directionality. Like before I even apply card finset.card conger, I might want to apply rewrite with the symmetry of equality. Because if I do that, then I'm working with a function from f and from fin n to f into a function from fin suck n to f, and that feels a little bit more natural, right? I think in either case, I'm going to have to write a version of this function which goes the other way, right? So I think what I'm going to have to write is something like the following function. The question is, how do I do this, right? Right, this is what I need. By exact, this is when I wonder if there's an exact, if I can apply something. Exact did not find any relevant lemmas. Did apply find any relevant lemmas? Well, it's not that I want lemmas, it's that I want functions. Basically, I want fin.alim. There's got to be something which says that if I have, right? Because I'm trying to produce a function here. And so that the question is, why am I not doing this? Why am I not doing k of this type? What's going on here? I need to close these parentheses. And basically I need to this. Basically what I want to get is that I have an element of fin suck, and I want to get either an element. It's either 0 or not. Maybe I need to case. Maybe I'll just sorry this out for now. Yeah, sorry it out and move on. Right, let's test. I mean, I think I'm going to need to write it anyway, but let's just sort of try and keep on with what we were doing. Right, immediately before we apply the card conger, I'm curious if we I know this is probably not going to be the right. Is it like E, capital EQ sim? Okay, I think that there's like a symmetry tactic, like symmetry. Like I just type that and it flips. Okay, I'm apparently wrong. Am I not right that there was that in MATLAB 3 though? 4 docs. It's MATLAB 4 docs. If I delete the 4. Tactics. Symmetry. Yeah. Did I misspell symmetry? No, it's just a tactic that does not exist. Okay. Back to trying to locate EQs. And equality is symmetric. Oh, is like an apply. So I would do apply EQ dot sim. Okay, but now it's telling me card conga is wrong. So okay, first of all, did this do what I expected it to do? First we had this, and then we had this. Yeah, that's about what I expected. Oh, and it's complaining now because this is now not the type of the function that it's supposed to be. Yeah, so what I want instead is this function. Right, instead of that, I now want to do that. Yeah, cool. Now I can intro things. And so now the thing that I intro, and instead of this, do like this mem product thing. Okay, this is, okay, so I intro these. Can I do like R cases on A with like A, B? This allowed? Can I like decompose the, like I see I have this, and now H of A, and now I want to rewrite mem product. And I guess also mem filter, because once I rewrite mem product, then there's going to be okay, but I also want to like simplify. This is a little annoying. Yeah, I don't know why it's like talking about multivariable polynomial eval to ring homomorphism. Like I don't want you to do any of these. I just want to like look at the very simple. All I want you to do is like change this expression into like A. Surely there must be like a tactic for this, but it's just like impossible to remember all of the tactics. It's like why can't the simplifier just deal with it? Whatever. Is it like okay? unfolds all structure projections. This might be it. Probably. Let's see if it exists. I want to do this at AJ, right? Oh, but it's an unknown tactic. No. Apparently I can't call unfold. Yeah, it's a very interesting because, like, again, I could decompose this. It's like I decompose, get closer and closer to what I'm supposed to have. Like at some point, like a congruence closure tactic should find what the function is. Okay, let's just try and like forget if I find that that's not the case. So, I mean, and this does seem to like. Let me like look at carefully. Something. And it's A. So this does do that simplification. It's just that it like is also simplifying things that I don't want it to simplify. Like I guess this coercion. Not degree. Right, because what is this conversion? This conversion is coercing the polynomial into a function, right? It's a multivariable polynomial and it's becoming like its coefficient function. Okay, so clearly we would want to like unfold, make Finstock function here, but we haven't defined the function yet, so let's just see what happens if we rewrite. Yeah, okay, things are getting like more and more workable. And BNS. Right. The point is that like make Finstock function being an element of function finset is equivalent to B being a function finset and also A being in the set. And so maybe we need to like just rewrite that. Yeah, maybe that's just the easiest way of going about it. Okay, let's try like writing this. Let's try writing this function. The point is that what I want is like to get from K, I want to like eliminate it into like one of either like 0 or a fin n. Surely there must be like a the sort of thing that I think is like MATLAB, data, fin, basic. An elimination principle. Yeah, well, I do want some kind of elimination principle. The thing is, I anticipate it to be like fin dot suck something. Fin dot suck embedding, maybe. What I really want to like, what I really want to do is establish an equivalence between like the unit type, like the unit type, like option, an equivalence between like option fin n and fin suck n. Is that what I like? I'm starting to remember like that this is related to the like the polynomial, the weird, yeah, fin suck equiv. Let's go to this definition. Fin suck equiv, right? It's an equivalence between multivariable polynomials over fin n plus 1 and polynomials over multivariable polynomials. But obviously I'm here in the middle of the like multivariable polynomial part of the library, and it's gonna like not load for me. Maybe I should look like fin suck equiv. Fin suck equiv. Logic equiv fin. Okay, here we go. Fin n plus 1 is equivalent to option fin n. Yeah, it's interesting that this is like a multivariable polynomial version of fin suck equiv, but then in a different namespace, it's something else. Okay, so back up to writing this function. By like foo is equal to option fin n like, how do I handle an equiv again? It's just like fin suck equiv. It'll cast it to a function for me. Okay. Why is it type mismatch? Type has type this, but it's expected to have type. This is really annoying. Like, how do I tell the to unknown constant finsuckequiv.toFun? Is it that I need a namespace? What is this called? Like fin.finsuckequiv? Okay, it was obviously happy here, right? It identified this, yes. It's an equivalence, finsuck. Oh, n is an explicit variable. That doesn't quite seem right to me. But whatever. So the answer is n. Okay. Like, this is something that. So this is sort of thing where like you get into an hour-long debate on the forum about why it should be changed, and you lose the debate with. I guess it's because it's like, it's not a function itself, it's like an equivalence, and so, yeah. Okay. Cases, ooh. Like a dot left, or a dot right, a dot second, exact a dot second. Exact a dot first applied to B. How does cases? How do I like tell cases? Cases E. I don't get it. How do I call cases in a way that makes the value appear? I call cases and now I have a fin n, but it has no name. This is how you get like dumb code like this. It's like, I don't know how to like use the cases tactic. Cases, like if I want to do like cases on some option type, I want to be able to decompose it. I want to like be able to have the name for the thing that I remove it for. Is it like Yeah, it's some val. It doesn't tell me. Weird. I feel like I should be able to call like show term, right? Some really wild, complicated thing. Okay. Well, that's this. Then the other thing that I sort of wanted to do was prove this lemma about like what happens when I assert that make fin suck function is in function fin set. So lemma make fin function mem function fin set. I feel like all of these names are sort of bad, but so what this says, like, what is this theorem? What I'm asserting is that for any like n natural and a here, or no, this a, I have the fact that a, this is now a function, is a member of function fin set. Who knows what A is? Who knows what B is? S. I guess this has to be true for like, I have to say S. Fin set F. This is true, and only F. This is where I really get to be thinking that like I should like define this differently, because like this is not getting into MATLAB like this. So I might as well change it now. So A is this, B is of this type, B, A. Okay, now that's good again. Basically the same thing has to happen here. Now we're talking about this function. This is in that if and only if A is in a function fin set and B is in S. Ooh. One equals by, sorry. Right, that feels okay. And now, of course, I have to go down because it's like, what have you done? You have something wrong. What I want is the function that takes like the prod, right? So like AB dot first, AB dot second. Yeah. cleaner if I write it this way. And so now what I do is I apply the function that I just, apply the lemma that I just made. Let's try and do some casework here to like split up AJ. Cases HA with a mem SS and foo and bar. Do I have to like, I don't know if I'm parsing that correctly. Yeah, I think it has to be like, problem is this works fine, but this needs to be decomposed further. Like this perhaps? Yeah, cool. So bar is obviously just BMS, and foo is just this statement about like evaluating A. I really like, do I need to? I guess I'll just call it like val AB0. Or I guess it's even just like a val A0. And then I do all these things. Can I like, is there like, I remember there's like a MATLAB 3 tactic about like split ifs or something. Just like, please decompose everything. Maybe I'll just like split, surely split exists, right? So I'll just do like split. Split. Tactic split failed. Is that not the case that split applies the constructor? Right. So I think maybe it has to be like apply and make or something. And dot make, maybe. Okay, surely if I do like apply question mark, it will tell me what's going on. Because like I have to apply something, and obviously like the constructor for and is like the thing that I want to apply. So Perhaps it will tell me what I should do. Huh. This is not what I wanted. Click apply. Refine. Maybe I can do like a refine to get around this. Don't know how to synthesize. Yeah, the thing is, like, there's only three. Like, does split ifs not exist? Like, I'm confused. Does split as a tactic not exist? The split tactic is useful for breaking the nested if and else mesh. Split. Wait, let me read the documentation. The split tactic is useful for breaking nested if, then, else, and match expressions into separate cases. Split. This is not what split does in MATLAB 3. Applies the constructor when the type of the target is inductive data type. I wish there were like, there should probably be some sort of guide as to like how to like find the right MATLAB 4 lemma. Is there like a constructor tactic? Constructor. Constructor. Beauteous. Not sure why that was so hard. Like, see, this is exactly what split used to do, but apparently, like, split has a different purpose now. Okay, how's it that I have 4 goals? I thought I had like, I feel like I should be more careful about like, how do I have 3 goals here? I have 1 goal, 1 goal, 1 goal, 3 goals. Because of the way that I apply card conquer. I guess I have to like prove all 3 of these things. So guess that is what is right. So focus on 1 goal, and now I do this. And now I think I want to apply constructor again, right? So constructor. Now I'm going to be asked to prove that A is an element of function Vincent. So this is exactly A mem FFS. Yep. This is also going to be like, this is going to be exact like B, the lemma about B. Yeah, B mem S. And the final thing is going to be a val A0. But how exactly are we going to apply a val A0? We have another thing, right? So this is another lemma we need. We need to be able to assert that this is simply A. Make fin suck function AB composed with fin suck is simply A. How did this get to like have all this? It's like it's because I like did this simp only. Okay, like at the end of all of this, I'm like deleting simp only, and it's going to be like completely fine, which is sort of annoying. Okay, but for now, let's copy this, make a new lemma. Okay, this is insane because I just pasted that, but that was not the thing that I expected to paste. This is like, okay, where was I? I just want to like confirm that it's totally broken. I was right here. I clicked on this. I right-clicked. And I clicked copy, which leads me to believe that like this string is in my clipboard. But when I go up here and I hit paste, it is definitely not in my clipboard. So that is wrong. Let me just like assess this further, right? If I go here, so if I right click, it says that there's like a copy, and it has Control C. So if I hit Command C here, now does it reside in my clipboard? No, it does not. That's very annoying. Anyway. So final attack, we are going to literally select it and copy it with Command C. And now we are going to do lemma. So this should be composed with this is the concept that that equals that. By sorry, let me just like just add like a whole bunch of variables here so that no one is confused. And also let me put this on a line where it's okay. So this is, yeah, this should in fact be like a simp lemma. Like if it were, I would like probably won't get into MATLAB in this form, but whatever. Let's go try rewriting with this. So let me like make my info view larger again. Rewrite using this. And now, like moment of truth, exact val A0. No goals. All right, so that's like 1/3 of this, 1/3 of 1/2 of it done. All right, so that seems sensible. What about here? What do we have to do here? Roll A, B. Okay, this is annoying. It's like A and B of the same type. Intros 1 and AB2. HAB1, HAB2. Okay, so all actually that's necessary here is this last condition, right? So this is like something, this is like the second, this is the second condition of card conquer. And it's that if A implies A equals B. But this in fact follows directly from the fact that like make fin sub function equals make fin sub function if and only if like A is equal to A and B is equal to B. Okay, so that's like another simple lemma. In fact, I think I'm confident enough in that I'm just going to sorry it out and take a look at what the last one is real quick. Okay. Let's do some intros, BHB. There exist A and HA such that, yes. And again, we don't actually need HB. We just need the fact that for any B, there do exist A and HA. Yeah. See, I feel like this is deceptive because actually like the type is, this is like the type of some prop. So I actually do have to like prove this HA too. It's not just like this random thing. I mean, really what should happen is that like, right, this should be like an equiv or something. Or sorry, the make this thing should be an equivalence. A lim-fin sub function should be like an equivalence. And it should be like somehow related to this. Let me go back. I wonder if there's like, I wonder if it's defined somewhere around here. In sock equiv. So this is like a stranger equivalence that like removes a particular I. Weird. What other things are in this file? Like sin sock equiv. Finsuck equiv last. Well, I think I want to use the more canonical one, which is finsuck equiv. Finsum finequiv. Yeah, that's another one. Okay, wait. Here. Fin n+1 to beta is equivalent to beta and fin n to beta. Yes, okay. This is what we were looking for. Okay. Equiv.pi finsuck. All right. This is what I want to use. So I want to, now that I have this, I would like to redefine. Okay, so like, first of all, let's like redefine this in terms of that. Just want to like delete all of this. I want to do equiv.pyfinsuck. The first argument is n. The next argument is f. Right? The type f is given as explicit argument. And then I want to do like the in fun of this equiv. Has type this, but it's expected to have type f. B-A-K. So it's this B-A-K. I don't remember if I'm supposed to indent when it's not tactic mode. I think I'm not actually supposed to indent when it's not tactic mode. I think that was like technically the MATLAB 3. Okay. And I bet these lemmas can be proved directly from this. Okay, so let me just recall, like, yeah, I thought this one would be fairly easy to prove. It's complaining about this, sorry, because there's nothing left to prove in that location, so I just need to prove here. There exists an A. What is the type of A? I'm confused. There exists. Yeah. Something have fin n to f times f. So the point is that I want to use fin n to f times f. To use B. I want to use equiv pi finsuck apply to B. complaining because it has type this, but it's expected to have the other type. Yeah. I wonder if I want to like rewrite everything to like put the other one first. Like to go to go all the way back up here, right? But like I apply card product. Before I apply card product, I could hypothetically apply like molcom. And that would like, so I first permute so that the FinSet card S is first, then FinSet card product. And so the types are like this. I think what I would have to do is this would have to be second and this would have to be first. The types here are probably permuted. Yeah, this is now no longer like a weird structure. I think this is the right order. Let's see if I got that order right. B mem. Okay, so it should be A mem S, B mem FFS, val B0, because A and B have exchanged their meanings. Probably this is like a weird nightmare of like not putting the right names in the right places. Like going back to like the exact question mark here and the exact question mark here. My hope is that I will be able to, I will be told like this is this, okay. Yeah, this is this. And this is about B0 maybe. Okay, let's just make sure that this is like just as uncomplicated as it used to be. Yeah, I think it is. And this is now totally valid. So I use this. Like, I feel like I need to like simplify here, like, because this is like some weird statement about like there exists something that satisfies this proposition. Yeah, okay. But again, I don't want to like use the use all these polynomial knot degree, polynomial. It's interesting that there's like finsuck equiv apply. All I really wanted to do here was like exists prop, I think. Equiv.toFun as COE apply. Yeah, just like exists prop. It's just that it turns into like a conjunction or something. Yeah. In fact, I can like probably rewrite. Constructor. Okay, so now I have a conjunction to prove. That's done using constructor. I think I have seen this advice somewhere before. Let's look at the separate things that we need to prove here. need to prove that equiv not too fun. B what's that dot filter? Okay, so here it might be acceptable to unfold like member of like a set product. I mean, maybe the first thing to do is like equiv to fun. Right. Point is that like B is a member of this filter when composed with finsuck. All simp. Let's just like consider all of these. To fun as co apply. Okay, I don't think that's particularly important. Equiv.py finsuck apply. That might be important. It's not done. And product. What is this? This is some other lemma. Okay, let's remove like the polynomials, but this time let's keep the equivalence ones and the finset ones. So it reduces to a bunch of conjunctions. I feel like I also want to apply memfilter at HB. And I expect the thing is, where do I have that B0 as an S? for all B. All B that are such a function. B is fin-set filter. Fun R polynomial eval R composed with fin.suck equals 0. Right. So if I rewrite mem filter at HB, it should be like some kind of conjunction, right? Yeah. So B is in the function fin set. Right. Okay. And so this is where I get the B0 is in S. Right. Mem function fin set. Did I write like some lemma or something? If you're a member of a function fin set, did I not write? Yeah. I guess it's just that it's like phrased weirdly. Yeah, I think all the like ingredients are here. I mean, that just what really needs to be the case is it just needs to be a lemma that says like you remember a function fin set if and only if for all A in type, f of A is in S. Like even this description is. And so this is just going to write like a different one. This is just going to be like right. This is actually going to be like agnostic about F, but it's going to say that like if F is a member of function fin set, A being some type with the requisite type classes, this is some fin set of B's, and F, A to B, F is in function fin set, if and only if, for all A, F, A in S. Sorry. So like returning down here. Casing on HB now, casing HB with HB, comma, HB prime maybe. Constructor. Exact HB0. Constructor. A. Apply HB. And at last, I need to use HB prime somehow. Polynomial eval B composed with fin suck. Right, let me just like, okay. Am I insane, or is this exact HB prime? I mean, yeah, okay, cool. Okay, and what do I have to do here? Make fin suck function equiv to fun first. All right, this looks like a job for, yeah, make fin suck function. So I have basically applied fin suck function to two things. So yeah, this looks like a job for unfold. Or like Refle, maybe? Refle. This be fun. Okay, apparently not. Unfold, make fin suck function. Function K. All right, so this is, I guess this is like functional extensionality time. Equiv and fun. I mean, the point is that like this is just equiv to fun, right? Something is a little bit like something is being a little bit trickier than it needs to be here. I'm going to take a quick break. Be back. Okay. Seems like the mic is working. Okay, cool. Okay, what's going on here? What's going on is that I unfold finsock function, and the point is that what I have here is 1k. K maps to this. And the point is that, like, equiv to fun, right? This is just like giving, like, the first, right? This is the first element of something, and then this is the second element of the same thing, which implies that it should actually, like, be very simply just the thing, right? Okay, well, that radically simplified things. Fin.cons. I'm now interested in what fin.cons is. Adding an element to the beginning of a tuple to get an n+1 tuple. Yes, okay. So this looks like, I suspect this is exactly what I've been doing. Is it that like it's exactly equal to this thing that I've defined here? Fin.cons takes in n, a function from I. Yeah, function from fin n to type. Again, I'm not exactly sure. Like fin.cons. Actually, let me like duplicate the tab before I do this. Fin.cons. Yeah, not sure. Okay, simplifying makes things much simpler apparently. Which is the one that introduced cons? This one. If I tell it not to use that, it does not have simp attribute. Okay, well, then why was it used? I feel like that's not a correct error message exactly. No, this is all not exactly what I want. What I want to use is the fact that like I have here like a tuple notation for some product. And I simply want to like, okay, it's time to do an example lemma. Example, A and B are types, and A is in A, B type B. What I would like to show is that actually maybe what I want is like AB is in A times B. What I want to show is that AB is in fact equal to AB dot first, AB dot second by the library search. What is the name of the? Tells me that this is exact ruffle. Okay, but okay, RFL. Maybe gosh, so hard to like find where I am. Okay, this is super dumb. I'm just going to include this as a lemma, and the maintainers can tell me later why I should know what the right lemma is in this situation. So this is the lemma, like make prod of projections. And then what I want to do is I want to like rewrite it backwards. So I want to go back down. Where was I? Here. Rewrite backwards this. Okay. I want to simplify this. Like equiv to fun. Okay, something is wrong. So like I have this equiv in fun, and equiv to fun. There must be like it must be something in the like definition of equiv that equiv Python suck. Go to the definition of equiv. Function right inverse in fun to fun. Sorry, what is this? G composed with F is the identity. The inverse fun. Okay, so what I have here is, okay, right inverse would be the other way around. So I think I want left inverse. Right, this is equiv to fun. What I don't quite understand is that this is an equiv to fun. It takes in 2 arguments, right? Right. All of this, no, what? So this is a function, and this is its inverse, right? Right, this is, okay, it's a function. Yeah, but like just this is a function, and just this is its inverse. What's it called again? Equiv dot left inv. Did that succeed in doing something? No goals. Yes, it proved it. Glorious. Hallelujah. Okay. But there's one sorry still up here. Was this sorry? This was something that seemed to me to be pretty clear. Right. My thinking was that this should follow exactly from the equality from HM and Q. Like, so these two actually were not going to be necessary. When I put that, yeah, it just like gives them no names, but of course it's fine. Yes, so unfold make int function. Oh. Can do unfold that, right? Okay, yet another excellent application of our make prod of proj. I wonder if it'll rewrite it twice. Oh, it doesn't even recognize that it's valid. Pattern is a variable. Oh, I need to go it backwards. Frankly, I've gone backwards twice. Probably the lemma should be written the other way. In fact, let's do that. See, this is where you like to sort of abstract. Basically, I want to say okay, look at HMKEQ and just use what you know about equiv. I think that the point is that equiv inverse function is like an equivalence, right? So if I apply the equiv inverse function to something, it's like a bijection. So, okay, well that's sufficient. It obviously found the right thing, but it also decided to split things up. Did it this? wonder if this like works. Yeah, apparently not. Okay. I mean, it's like this should be like in the library search though, like library, like our cases each make equal with foo and bar, and then exact something. Of course, I have to write things in a sensible way. Yay, find something. What is the name of the lemma, pray tell? Okay. Of course, this is like maybe first. All right, that looks like a proof for this part. Cool. Let's move on to the next part then. Which I decided was this one. And I have a little note to myself that I'm going to need to use polynomial.card roots. Right, okay, so let's inspect the goal here and try and figure out what we're trying to show. I don't think I need h first half. Like, I'll just clear it from my proof here so that I don't have to look at it. Finset card of finset filter of this equals 0 and this equals 0 is less than or equal to I times finset.card of s to the n. Right. So the nature of what's going on here, as I recall from last time, is that, right, we have this, right? So like for any particular choice of the n values here, those determine like then we like if for those values we get that the like composition with suck is non-zero, then we know by the number of roots in a polynomial is at most I that like for any particular choice of these, there are at most I choices of the last element that make this turn out to be 0. So the question is, how do we want to go about this? Right, the point is that that is less than that cardinality of this. But the point really is that the cardinality of this is the sum over all like choices of the first n values of like how many polynomials there are. Maybe I should write that out. Yeah, I should write that like proof. yes, so like just to say that this, right, this is equal to like the sum over a bunch of different over a bunch of s to the n different values in that thin set. How would we go about proving that that sum would be equal to the cardinality here? Like maybe what we want to do is like prove something. Like we said, function fin set was the set of, was this, right? But maybe we wanted like be able to rewrite function fin set into like function fin set mat. Right. It's the image under like this sort of equivalence. Hey, it'd be a good idea just to call it quits for tonight. We already proved this one long one. Seems like that was about like half of the work, and then the remaining half of the work will be proving this other one. Okay, take care, everyone.